Friends, good morning to all of you. Students in class 12 physics, today's topic is apparent and real time. Okay, for understood about the apparent and real time, just we are going to explain it or we are trying to understood with an example. Let's we have a container which is filled with transparent liquid for in which inside the container at the bottom an object is placed at point O. Then to form the image of the object we need two rays in which one is moving straight or parallel to the interface surface perpendicular to the interface surface, and the another ray which is an inclined ray which is moving in the direction of O to B, because this is denser medium and upper side of the interface surface is air which is rarer medium. Then when the light is emits out or emerge out from the denser medium to rarer medium, you will learn in the first lecture that the light is bends away from the normal. If we draw a normal at this point, let's say M or M and S, then we observe it will not moving in its actual direction, it will slightly bends away from the normal. In such a way, this is angle of incidence I, and in the air medium, this is angle of refraction, okay, which is R. When a person wants to see that object from the outside, then it experience that the object is at location I. Therefore, the scene's condition of the object inside the dense liquid is just or it rises above its actual position. So, here AO is the actual height and AI is the apparent height. We need to derive a relation in between the apparent and actual height. Okay, in the form of its height and in the form of speed of light. Okay, now let's say the refractive index of the liquid for dense medium is mu 2, which is equal to mu, and the refractive index of air is mu 1, and as you know the refractive index of air is about 1, so we are using it is 1 only. Okay, now here the angle here OA is parallel to the normal and S, therefore this angle is also angle R, because these are alternate interior angles. And here when let's say this is C, when the ray BC press in the backward direction, then it meets OA and I, therefore the angle NB, this is the point B, and BC is equal to angle IBO because of co-interior angle. So if this angle is R, therefore this angle is also R. Clear? Now this see here, this is the total angle and B and S I is equal to AIB. Clear? It is also the interior region. Now we have two triangles in the figure. Condition is the object is placed in the dense medium and two rays are coming from the object in the rarer medium. One is perpendicular to the interface surface and one is making an angle with the interface surface. Okay, so in triangle OAB, in triangle OAB, we have to calculate this hypotenuse and we have the perpendicular. So sin I is equal to AB upon OB and in triangle IAB, we have sin R. Sin R is equal to AB upon BI. Clear? Now, according to law of refraction for OBC, okay? According to Snell's law for ray OBC, the ratio of angle of sine of incidence angle and sine of refraction angle is equal to refractive index of second medium with respect to first, that is equal to mu. Clear? As we use here, mu1 is 1 and mu2 is mu. Okay. Therefore, we have the value mu is equal to sin I. Sin I is AB upon OB and sin R. Sin R is AB upon BI. Clear? Now this AB cancel and we get the final result for the mu is BI upon OB. Okay, now if for very small angle of incidence and refraction, point B is very close to point A, then we conclude that for a small angle of incidence I, B is very close to A, very close to A. Therefore, we can conclude that BO is equal to AO, which is equal to height of object, and BI is equal to AI, which is height of image, or we can say depth of object and depth of image. Therefore, this result mu is equal to HI and HO, and this is called real depth. 2 real depth. Real depth. Okay. Therefore, by taking reversing reciprocal of it, we get 1 upon mu is equal to what is it? Here we are using I in denominator and this is not 2 with respect to second because responsible medium is air. What medium is responsible to reflection? So we are using here 1 is to 2. This result we get 1 upon mu. So this is also 1 upon mu. Sorry, this will be taken here. This. Finally we get from here by taking reciprocal, mu is equal to real depth upon apparent depth. Just reciprocal of it. Apparent depth. This is the relation between the refractive index and the real and apparent depth. Okay. Now, here we find that there should be a apparent shift. Apparent shift is the distance between the object and image. If this result is d, okay, and the total length of the liquid is t, therefore, just note down it. Okay. Next is apparent shift. Apparent, yes. Apparent shift. Apparent shift we have mu is equal to OA upon AI. Figure. Now, from figure, OA is equal to T and this is apparent shift. So, AI is equal to OA minus this result OI. Clear? Therefore, we have AI is T minus D, where D is apparent shift. Apparent shift. Okay? By using these two values in the relation, we get mu is equal to T upon T minus D. Clear? Now we will calculate here the value of D by multiplying mu T minus D is equal to T. We get here mu T minus mu D equal to T. Now this mu D is shifted here. We get mu D is equal to mu T minus T. Here T is common. Mu minus 1. Okay. Now calculate the value of apparent shift, which is B is equal to T upon mu minus 1 upon mu. Clear? By solving it, you will get B is equal to P 1 minus 1 upon mu. This is the relation between the apparent shift and the refractive index. This is relation between apparent shift and refractive index. Okay. Next we have total internal reflection. Done? Next we have total internal reflection. Okay, just we understood about what is total internal reflection. Here we have two basic conditions for internally reflected of light or reflection of light. Just we have these two conditions first. Condition for total internal reflection, or we say directly TIR. Okay. First condition is the light should be travels from denser medium to the rarer medium. Light should be travels from denser medium to rarer medium. Okay, and the second condition is the angle of incidence should be greater than the angle of critical angle for the pair of medium. The angle of incidence should be greater than the angle of critical angle for given pair of medium. Okay, we understood about what is the critical angle. Okay, the point is critical angle. Okay, now what is it? Let us understand about with the help of an example. Let's say this is the denser medium, okay, and above is the rarer medium. As you learn, just in the apparent and real. Here, if a light is traveling from the denser medium as the first condition, okay, like this, or we say in this, clear? Then it makes an angle of incidence with the norm. Makes an angle of incidence in the with the normal. Let's say this is angle of incidence 1 for the first plane. Okay, and you know, if the light is travels from the denser medium to rarer medium, it bends away from the normal. If this is the actual path of this light, then when it is emerged out in the rarer medium, it bends away. Clear? This is refracted ray 1. If we increase the value of angle of incidence for the given pair of media, like the second ray which is traveling by angle of incidence I2, we find that this is the actual path, and because it emerged out from the denser to rarer medium, it bends in the direction of 2. Clear? This is your second incidence. If we for the another incidence ray with the larger angle by 2, then we observe that the line is nearly pass with the interface medium. It is the third case, and this is next angle I2. If we increase just 1 or 2 degree of incidence angle for the fourth incidence ray like this, then we find that the angle of refraction for the fourth ray is equal to 9. Okay, this is 4. So this is the last value, or just below it the last value of the angle of incidence for which the refracted angle in the rarer medium is become 90. So this angle I4 is equal to critical angle for which refractive angle becomes 90. Okay, and if you increase 1 degree for the fifth ray, this is your fifth ray, for the angle I, which is greater than the critical angle, we find that the third ray is internally reflected in the denser medium and follows the law of reflection. Okay, and it moves in this direction. This is R1, this is R1, R2, R3, R4, and this is R5. And it is observed that I5 is followed the law of reflection, and the angle of reflection R is equal to angle of incidence I, which is greater than the critical angle. Okay, so what is critical angle? Right? The critical angle is the angle of incidence. The critical angle is the angle of incidence for which angle of refraction in rarer medium, equals to 90. Okay, this is critical angle. Okay, now total internal reflection. Total internal reflection is the phenomena of light. Is the phenomena of light traveling from denser medium traveling from denser medium to rarer medium when incidence angle is greater than critical angle. The light internally reflected, the ray internally reflected in the denser medium, Okay, this is total internal reflection, in which the incidence ray is internally reflected for incidence angle greater than its critical angle without any loss of energy. इसको write in the bracket, without any loss of intensity of light. It is the important part and the condition. Because of that, the optical fiber, the phenomena is used because there is no loss of energy and the light entering from in the optical fiber from one end is 100% transmitted at the other end without any loss of intensity of light. Hence, the image of an object is completely formed by the optical fiber with the help of this special principle, that is total internal reflection. This is also the principle for the formation of the rainbow, that is the natural beauty of the earth. Formation of rainbow after the rain, if the sky is sunny, okay, और sunny day जब होगा, then we find the rainbow after the rain or after the rain. Okay. Next we have the relation between the critical angle and the refractive index of the denser and rarer medium. Okay. Right, relation between critical angle and refractive index of the medium. Relation between critical angle and refractive index. Okay. For fourth incidence ray, ठीक है, here this is normal and a ray for which angle I equal to its critical angle, the refracted ray is having angle of 90. Clear? Therefore, according to Snell's law, ratio of sine of angle of incidence to sine of angle of refraction is equal to refractive index of denser medium to rarer medium. It is clear? Here we are using refractive index of denser medium is mu b and refractive index of rarer medium is mu r. And here rarer medium we say in here and it is any medium. Okay? In medium. Clear? Therefore, we are using mu r is equal to 1 and mu d equal to mu 1 as we done in the apparatus earlier. So this result gives result mu only. Therefore, we have the angle I equal to angle C and angle R is equal to 90 from figure that we get sin C upon 1 or sin 90 equal to mu. Clear? Therefore, sin C one minute. Here we have again reflection is done due to the first medium. Okay. So this result is refractive index of rarer medium to denser medium, and this result we have 1 upon mu. So we correct it. 1 upon mu is equal to sin C upon sin 90. Clear? Therefore, we get sin C is equal to 1 upon mu. This we calculate by using refractive index of denser medium is 1 upon sin C. This is the relation between refractive index and the critical angle of the denser medium, for which the refractive angle is 90. Okay. This is required series.